Okay, let's get into it. For today's deep dive, I want you to picture a huge live event, a concert, maybe a big sports broadcast.
Right.
You've got, say, 8 different HD cameras, all feeding video back to a control room that might be kilometers away.
A pretty standard setup for a professional broadcast.
Exactly. And you need that signal to be perfect, uncompressed, no delay. The last thing you want is to run 8 separate, heavy, and very expensive coax cables.
Definitely not.
So we're looking at the solution, the Thor Broadcast F-8SDI-3G-TxR-RM. Our mission today is to figure out why this piece of gear is such a workhorse for the pros.
Well, what's really fascinating here, I think, is how it's all about efficiency. I mean, at its core, this is a transmitter and receiver kit.
A matched pair.
A matched pair, yeah. And its whole job is to move 8 channels of uncompressed 3G-SDI. That's a high-speed signal, up to 3 gigabits per second.
And it moves all of that over what?
A single hair-thin strand of optical fiber. The real insight for you, the user, is just a massive savings in cost and labor.
That really is the key detail, isn't it? 8 separate high-speed video feeds, all packed onto one single fiber. Which, I mean, that immediately begs the question, how? How do you do that without all the signals just crashing into each other?
That's where we get into the really cool tech. It's a concept called CWDM.
CWDM.
Right. It stands for Coarse Wavelength Division Multiplexing. And the easiest way to think about it is, imagine you're shining 8 different colored lasers down the same glass tunnel.
Huh, okay.
Each color is a different wavelength, and each wavelength carries one of your video channels. They travel together, but because they're different colors, they don't interfere. And then they're all sorted out perfectly at the other end.
That makes a lot of sense. But, with the big push to move everything to IP networks, why are pros still sticking with dedicated SDI over fiber? Wouldn't it be cheaper to just compress the video and send it over standard Ethernet?
That's a great question, and it really hits on signal integrity. When you're talking live broadcast, you just can't afford compression artifacts.
Right, the little blocky bits you sometimes see.
Exactly. Or even the tiny but still noticeable delay that comes from, packing and unpacking those IP packets. SDI over fiber gives you basically zero latency and completely uncompressed quality.
So it's about reliability.
It's all about reliability. And what's more, if 8 channels isn't enough for, say, a huge stadium setup, you can scale this up even more with something called DWDM, Dense Wavelength Division Multiplexing.
And that gets you.
That can get you up to 160 channels on that same single fiber.
160. Wow. Okay, so if you're pushing a signal across, say, 40 kilometers, that kind of density it's just revolutionary. Speaking of distance, how robust is the connection itself?
Oh, it's extremely robust. The system works over standard single-mode or multi-mode fiber, and you can get versions with a 35 dB optical budget.
Which, in practical terms, means?
It means you can easily send a signal over 40 kilometers. And it uses these really rugged standard connectors. STPC for the fiber, which is that common twist lock type, and then standard BNCs for the video.
So moving 8 channels of video sounds like it should be a configuration nightmare. What's the real-world experience like for the person actually setting this up?
I think this is its biggest selling point. It's just simple. These units are genuinely plug and play.
No software, no complicated menus.
Nothing. No configuration at all.
Okay.
The system is designed to automatically adjust with whatever you plug into it. SD, HD, 3G, SDI. It doesn't matter. It just locks onto the signal. You connect it, and it goes.
That's a huge operational advantage, but it does make me wonder about signal quality. When a signal travels that far, the timing can get a little messy, right?
Right.
Does all that automatic handling compromise the video itself?
Not at all. And that's because of 2 critical features. First, it has input equalization, which sort of cleans up any sloppy signals coming into the box.
Okay.
But the most important part is the reclocking. It has reclocking for the SDI video. You think of it like a digital tune-up. It just perfectly resets the timing of the signal before it leaves the box, so what you get out is crystal clear. And it passes all the embedded audio and other data untouched.
And physically, I assume it's built for a professional rack room.
Exactly. It's a standard 1RU 19-inch rack mount unit. So it fits right in and keeps everything clean. Plus, it's got a whole bank of little status LEDs on the front for every channel, so you can see the health of your video and your fiber link at a glance.
So to sort of wrap this all up, the value of a system like this is it's this powerful, invisible piece of infrastructure. It cuts costs by moving a huge amount of uncompressed, high-quality video over vast distances with maximum density and minimum hassle.
That's it. It just works. It's a piece of foundational hardware that automatically manages all this incredibly complex physics and timing, and it's completely invisible to us when we're watching the final broadcast.
Right.
And that raises a really interesting question for you to think about. Considering how vital these specialized fiber systems are for guaranteeing that perfect real-time video,
Hmm.
how long do you think SDI will stay the king in broadcasting before IP networks finally manage to close that latency and reliability gap for good?